Welcome everyone. As we look at the landscape of big data in 2026, we aren't just talking about more data, we are talking about intelligent convergence. The fundamental shift is that we have stopped treating storage, processing, and AI as a separate silos. Today, big data is the unified framework that allows us to handle massive, diverse volumes instantaneously. If your application doesn't feel live, it's already a legacy. So here is the deal. Back in the day, we used to treat data like it was in the separate buckets. One for storage, one for processing, one for AI. It was a mess. But in 2026, these walls have totally crumbled. We call it intelligent convergence. It's the idea that everything from the moment a piece of data is born to the moment an AI makes a decision based on it happens in one smooth, connected. We aren't just moving data anymore. We are building an intelligent brain for the whole company. The unified data flow. This is the central panorama of a modern data is a landscape of moving parts that all speaks the same language. On the left we see twin headwaters, historical logs that would be like batch processing and a real-time events that is a stream processing. In the past these never touched, but today they flow directly into a central unified engine. Imagine a massive river system where slow steady currents that is yesterday's data, lighting fast rapids that is today's events merge into a single hub. This hub feeds the data lakehouse which acts as a core of the operation. From there the data does not just sit still, it branches out to power everything from automated drone monitoring to high level AI analytics. Let's dive into a continuous circular ecosystem where nothing is wasted and everything is live. In the unified processing, modern IT developers must master engines like Apache Flink or Spark to achieve unified processing. The goal here is single logic applying the exact same code to historical data and live data to ensure the results match perfectly. Remember the nightmare of writing two different scripts, one for monthly report and another for real-time dashboards, and the spending hours wondering why the numbers didn't match. Those days are gone. We use a magical funnel approach whether data is second old or decade old, it goes through the same logic. For example, when the customer checks their bank balance, they see their transactions from 3 years ago and the coffee they bought 3 seconds ago, processed by the same engine, providing one consistent instant results. Moving on to the next, we have data lakehouse architecture. The data lakehouse is a hybrid champion of 2026. It uses technologies like Delta Lake or Apache Iceberg to bring the ACID transactions, the reliability of a database, to the cheap, flexible storage of a data lake. This is the best of both the worlds. Stage. Think of a data lake as a massive, messy warehouse where you can store anything for cheap cost, but finding a specific screw is impossible. A data warehouse is like high-end boutique, clean but expensive and rigid. The lakehouse is a hybrid. We have built a structural bridge of rules and organizations over the messy warehouse. Now we can run a high-performance SQL queries directly on raw files. We get the organization's boutique with price tag and flexibility of the warehouse. In the next point we have event streams and vector AI. This is where big data meets the cutting edge of generative AI. We use event streaming like Kafka as a central nervous system to broadcast events, while vector databases like Pinecone act as the AI's long-term memory by storing embedding mathematical map of meaning. If an event streaming is the nervous system that feels a truck move or a customer click, vector databases are the intellectual memory. AI does not see words, it sees patterns. When we store data as vectors, we are giving the AI a way to do a similar search. For instance, if a lawyer asks an AI for a case summary, the system does not just look for the word contract, it searches the database for the concept of the contract. It's the difference between a mission that matches the word and a mission that understands the context. And at the last, we have serverless data engineering. This is the final stage of is all about operational efficiency through serverless and multi-cloud architectures. By decoupling compute from storage, tools like BigQuery or Snowflake allows us to scale our processing power independently of our data size. This is the ultimate pay-as-you-go model. In the old days, we had to buy the bus or a server and pay for the gas even if only one person was riding it. Serverless is like calling an Uber for your data. When a massive spike hits, like a championship game or a Black Friday sales, the system automatically scales up to 1000 cars to handle the load. The second is the rush is over. Those cars vanish and your bill drops back to nearly zero. You are no longer paying for idle hardware. You are only paying for those the seconds your code is actually running. So the conclusion is from data management to real time intelligence. In 2026, the metric of success has shifted from how much data you can store to how fast you can make that data useful. The big data developer is no longer a liberation of the past, but an architect of the present, building systems that don't just record history, they react to it. Look, if there is one thing to take away from all this, it's that big data isn't specialty anymore. It's the new baseline. We have moved past that era of just piling up stuff in a digital basement and hoping it's useful later. Today, your value as a developer comes down to one thing, that is, can you make the data alive? Whether you are using vectors for AI or serverless streams for scaling, you are essentially building a system that can think and act in the moment. If you can bridge the gap between a massive archive and an instant decision, you are not just a coder, you are the one holding the key to the kingdom. Thank you for watching. We'll catch up with the next interesting video. Until then, take care. Bye bye.